Hi everyone, this is stage 3 of the grade booster pack. So this is looking at reasoning. So this is all to do with, can you explain ideas in either short or in particular the long response questions. So this is a real skill. And a lot of my students very often say they understand the physics, but they got only 1 or 2 marks on a long response question. This is really, really common. So lots and lots of key points here. So to start with, just how many marks are missed and where are they missed? So not fully understanding concepts, that's a really big idea. Vague explanations, we'll come on to that later on. The terminology, that's got to be correct and used correctly. Mixing up different quantities. And probably the big one is the weak reasoning in explanation questions. So we'll come on to some strategies on how to deal with that later on. The typical examiner's comments, so very often the students will state the correct physics but don't link it to the question. So that's a very important idea, as we'll see later on. And students will just describe what's happening rather than explaining and linking that to physics principles. Okay, so the key points we need to consider are these ones. So the definitions and laws, you really have to know these so well you can access them instantly and use them confidently. So not just memorize them, you need to understand them. That's very, very important. Apply the principles to the situation. So very often the question might say, with reference to Newton's laws, explain what's happening in this situation. And students will just write out Newton's laws without applying it to the situation. Clarity of explanation, we'll talk about that later on. So the idea that if you just say it accelerates or something without specifying what it is, then you're going to lose marks. So if you just say because of this, typically a student might say the resistance changes because of temperature, and they don't say it's the resistance of the thermistor. So it's that clarity which is very important. Connectives, so this is a good use of the English language. Can you link together ideas? So if you're telling a story, you need to say initially or at the start, and then therefore or this is because, and after some time has passed or eventually. So you're linking all these ideas together. And then practice explaining. This is so important. So if you cannot explain these ideas either out loud or to somebody else, then you do not understand them. So this requires practice, linking together ideas. So physics explanation is a language. Like practicing any other language, you have to practice it out loud. Very, very important. So in order to practice all these ideas and all these skills, let's have a look at an exam question. So this is from mechanics, very typical question. It's a variation on an exam question. So what you could do here is pause the video, read the question thoroughly, and maybe attempt this, spend 5 or 10 minutes writing down what you would think is the correct answer. So let's have a look. So we've released an object from rest above a container of liquid. It falls vertically in the air and then in the liquid. And we have this velocity time graph as shown. Describe and explain how the acceleration changes from when it enters the liquid until reaching the bottom of the container. So let's have a look at a typical student answer, or a not very good student answer. So let's have a read of this. So a student says, when the ball enters the liquid, its acceleration decreases because the liquid slows it down. The velocity becomes smaller because the liquid is thick and resists the motion. The ball eventually reaches the bottom because it is heavy. At first the acceleration is high and it gets lower as the ball moves through the liquid because the forces act on the ball and it loses energy in the liquid. The acceleration becomes 0 when it reaches the bottom. At first reading, or first glance, that looks okay. That looks like a reasonable answer, but we need to unpick that and spot the problems with it. And there's a number of issues with it. So let's have a look at the problems and the feedback. So there are several issues here. So the lack of linking ideas and explaining what's happening. So it looks okay on the surface, but in reality, it doesn't actually answer the question. The student says its acceleration decreases because the liquid slows it down. Well, no, that slows down so the velocity decreases. The acceleration doesn't decrease because of that directly. The velocity becomes smaller because the liquid is thick. Yes, but not just because of that. We need to explain, well, why is there a deceleration? Resist the motion, that's too vague. Because it is heavy, well, yes it is, but we haven't really added anything to the explanation. The acceleration is high, but then it gets lower. Okay, well that's true. As it moves through the liquid, well, why? Because forces, which forces? It loses energy. Well, we're not interested in energy particularly. We're more interested in forces and acceleration. it becomes 0 when it reaches the bottom. Well, it's not 0 on here, so maybe it will do when it's eventually stopped. So actually they've said very little of any merit here, so probably only 2 marks. So let's see what's going on. They haven't talked about forces, which forces, resultant forces, and how that links to acceleration, F equals ma. The vague language is problematic, so the liquid slows it down is no good. Forces act, which forces, loses energy, we're not particularly interested in energy. This idea the acceleration becomes 0 when it reaches the bottom, well, that's too vague and probably not true depending on what they mean. The velocity becomes 0, and when it stopped moving, the acceleration becomes 0, but something would need to decelerate it when it hits the bottom, so that's too vague. I haven't talked about the forces, so weight, drag, upthrust. We could talk about upthrust, although that's not a big force. And then the structure, it's not logically ordered and connected. So what at first glance looked like a reasonable answer actually would only get 2 marks, or possibly only 1 mark, depending on the mark scheme. So we really need to work out how to improve this answer. Let's have a look at a model answer, I should say, model answer, or a better answer. Okay, so before we go through these key points, it's useful to identify what is happening in terms of the forces. So we have the weight acting down from the centre of gravity at all times, that doesn't change. When the ball enters a liquid, we have a large velocity, so we have a large drag acting upwards. So the size of these, the relative size of these forces is really important. D minus W will be large, so we have a resultant force acting upwards. So we have a deceleration, which is why we have a change of velocity. As the ball slows down, then because of objects moving through liquid, the drag force will reduce. It's still bigger than the weight, so we still have a resultant force acting upwards, but now it's smaller than it was before, so the deceleration is reduced. And then finally, eventually, we reach the terminal velocity where the ball is moving so slowly that now the drag force is equal to the weight. Now, very often students are used to this idea from GCSE, and they're familiar with terminal velocity balance forces. So this is what we have here. But we've got to this terminal velocity in a slightly different way than perhaps we're used to. So let's have a look at the best answer. So initially we have that connective. So we're telling a story at the start, the point where we're interested in. The drag force upwards, we've identified the force and the direction, is greater than the weight of the ball. We could say the weight downwards. So there's a lot packed into that sentence. Correct terminology, we've identified, we've compared the forces, and we've talked about when it's happening. So that's another connective, there is a resultant force upwards. So we've talked about the forces, and then we've made reference to the resultant force, which causes the ball to decelerate. So because we have a resultant force acting upwards, we have a deceleration. We could say according to Newton's second law, or F equals ma. And then we say, as the speed decreases, the resistive force decreases. So we're linking together the speed and the drag force. And therefore, or so, the resultant force decreases and deceleration decreases. So we've explained this whole stage, or all these different stages, as we did at the start, but for a lower speed. So lower speed, lower drag, lower resultant force, lower deceleration. And we could also link that to what's going on here. So we have a steep gradient initially, which means a large deceleration. A little bit later, the object is still slowing down, but now the gradient has reduced, which means the deceleration has reduced. Eventually, very good connective there. That means at the end of this story, or when we reach this flat line, the resistive force, the drag force, is now equal to the weight. So the resultant force is 0 and the acceleration is 0. So we've actually described 3 stages here. We've talked about large deceleration due to large drag force, large resultant force, F equals ma, large deceleration. Then we've got a slightly reduced deceleration because we have a lower velocity, a slightly reduced drag force, therefore a reduced resultant force, until we have a flat line here, which means the gradient is 0, the deceleration or acceleration is 0, because the forces are balanced, so there is no resultant force. So lots of terminology, we're telling a story, we've used connectives, and we've linked together all the ideas. So this is the type of thing that you need to practice in the exam. So what I recommend you do now is look at the booster pack, the stage 3, and practice some of those longer response questions using these key points that we've talked about. Good luck with that, and I'll see you in the next stage, stage 4.